Welcome to all of you. In this lecture, we are going to realize 74192 mod up counter using multisim. Two different mod counters are being realized over here. First one, design of up counter to count from 5 to 8. Second one, design of up counter to count from 2 to 6. A detailed description about both of these two is provided in another video, whose link will be given in the description box. You can just go through that in detail and then you can come back over here so that you can have a better understanding of step-by-step operation. So in this video, I'll be concentrating more on the multisim rather than the design of these two. But anyhow, the circuit related to these two will be shown in this presentation. So this was the general realization, the inputs as well as the output realization, and this was the mode table with respect to 74192. Now let us get into the first design. Design a up counter to count from 5 to 8. That is n value is equal to 4 using 74192. Now let us get into the truth table of it. See, this is the truth table. It is going to start from the value 5, 0, 1, 0, 1, and it is going to end up with 8, 1, 0, 0, 0. After 8, it must come back to the value 5. That's what the procedure. So this was the mode table. In the mode table, we are going to make use of this mode, that is up count one mode and another preset another. So these two will be utilized in order to make a design of this one. Now let us get into the actual design part. As I told you before, the detailed description of the design is provided in the another video. Please refer that video for the details. So here I will be just providing you the details in a very brief manner. Now this is the starting point 5. So after 5, then 6, 7, 8. So in a sequential count, after 8 by default it will enter into the 9. So 9 is the value that we don't want to be displayed. Therefore what we do is, from the value 9, which are all the bits equal to 1, those two will be considered. That is Q0 and then Q3 will be considered. So those two bits will be passed through a logical gate in such a way that the output of that logical gate at this particular instant must be equal to 0, because the output of that logical gate will be given to the parallel load operation so that the parallel value 5 can be loaded to the output. Parallel load is active low signal. Therefore, we want only at that particular instant output of this gate to be low. So for that, suitable gate is the NAND gate. So we can verify Q0, Q3 both are equal to 1 at this particular instant. When we give 1 and 1 as input to this NAND gate, output will be equal to 0. That 0 will be given to the parallel load so that the output will get loaded with this parallel data 5. And we can also verify that in any other instant among these count values, the output of this gate will remain as 1. So we can verify that. So this is Q0. So this is 0 and 1. So output is 1. So here 1 and 0 output is 1. And here 0 and 0 output is 1. And 1 and 0 output of the gate will remain as 1. So in all other cases, output of this gate will be equal to 1. Only at this instant, the output will become 0, which will be given to the parallel load, which will make the value 5 to be loaded asynchronously to the output. Now these are all the steps to be followed, the connection and the steps. So I'll be just going through the steps. So set preset to 0101, that is the value of D0 to D3 we have to refer. So D3 0, D2 is equal to 1, D1 is equal to 0 and D0 is equal to 1. So this is the preset value equal to 5. Then initialize the output to 0101, that is the same value, by setting PL is equal to 0 as a one-time measure. The very first time when we are configuring, we have to make PL is equal to 0. Then this will get parallelly loaded to the output. Then after, the count will continue. Otherwise also we need not worry. We can simply say So start the count value. By default, when it reaches to the maximum count, it will come back to the value 5 and it will continue. After one cycle, it will stand back with the original value. You can also make a follow-up of that. Then connect the feedback line to the PL. So after this one-time measure, we must connect the output of the logical gate to the PL and then apply the clock pulse. So by default, it is going to make the counting operation, that is up count clock we have to connect CPU. Now getting into the circuit realization. So this is what the circuit realization. So as I told you before, the Q0 and Q3 has to be passed through this logical gate and output of the logical gate has to be connected to the PL. The very first step, as I told, PL must be set equal to 0. That is not shown over here. So that, as I told you, so it is there in the another view. Please refer to that one. So this is what the truth table. So in this truth table, these 4 values are required. This 9, that is not going to appear, but in a sequential count after 8 it will go to 9, and by default in an asynchronous mode the value 5 will get reloaded. And as I told you before, we are going to make use of 2 modes. One is the preset and one more is the upcount operation. Right? Now let us get into the multisim procedure. With respect to the multisim, we had already gone through the regular counting operation of 74192. So I will be just updating the same circuit so that we can go through the mod counter. Right? So let us have a reference to the circuit once. So this is what the circuit we need to design. So first thing, so we need to first make use of this NAND gate, and then for the NAND gate input is Q0 and Q3 and its output has to be connected to the PL. So let us first go through that. So let us first take the NAND gate. So the NAND gate, it is already selected. So let us take that. So place the NAND gate over here. Well, I don't want any other gates, so I'll just close this one. So it will be just rotating. You press Ctrl R, it will get rotated. So the input for this is Q3, the MSB bit, and one more is Q0, so that is what the LSB bit. Right, so input has been given. Now this must be given to the parallel load, so I have to take out this one and clear. It is connected to ground, that is fine. So first part is done. As a continuation, see the input data lines must be set to the value 1010 with respect to D3 to D0. If we consider, then it is 0101. So that we have to provide. See, both VCC and ground are available. The VCC is 1 and ground is going to be 0. A is the LSP and D is the MSP. So let us go through it once again. The D0 is 1, D2 is 1. D0 is the LSP. And then this corresponds to D2, right? And remaining, I'm just going to connect that to the ground. So input is done. And as I told you before, as a first time measure, the PL will be connected to the ground so that the first value will get loaded. But I also told that after first cycle completion, by default the value will set to 5. So I will be following this second procedure. I am not going to alter this circuit anymore. So I just want to have these values. but for the first cycle I am not exactly going to get these values. From the second cycle I will be getting that, as I told you before, right? So let us run this circuit. Any more requirements? No, I don't think so. Let us run this one. So first cycle, obviously I'm not getting any proper values. Now 5, 6, 7, 8, and then so as you can observe, I'm not getting the value 9. It will be starting from 0, 1, 0, 1, and then it is continuing up to 8, then 5, once again back, right? As you can observe. So this was the one design. So with respect to this value, yeah, as you can observe, this is the MSB bit, this is the MSB bit. So starting from the value 5, it is reaching up to 8, and then it is coming back to the value 5, right? Let us get into the one more design. Design a up counter to count from 2 to 6, that is n value will be equal to 5 using 74192. Now the procedure remains as it is. So we are going to have this truth table. So it has to come from 2 to 6. So this is what the value 2, and up to 6 it has to count. And as per the procedure, by default sequential count, after 6 it will enter into 7. We don't want this 7 to be displayed. Instead we want again back with the value 2. So we are using the values of 7, that is, which are all the bits 1, that has to be connected through the NAND gate, and its output has to be given to the PL. That's what the procedure followed before. Same here also, but here 3 bits are having the value 1 in this particular case. Therefore we have to make use of 3 input NAND gate. Same you can also verify in the previous values, that is from 2 to 6. See, any combination of over here will not make the output of the NAND gate equal to 0. Only at this particular combination the output of the NAND gate will be equal to 0, because of which this parallel data will get loaded to the output. So now it has been initialized to the value 2, and then the same value we are assuming it is there at the output, and then regular counting operation will continue. Right, so let us get into the multisim directly, and again here also we are going to make use of two states, that is, one is the preset as well as the upcount operation. Now let us get into the multisim procedure. So let us get into this multisim. So I'll be just updating the previous circuit. So we don't want this one, and then need to have an update with respect to the connections. So we want this one, then value 2 has to be loaded, so there must be an update. So let us just delete all these things. Now with respect to that, so this is what the VCC, the value 2, all others will be connected to the ground, value 0, so these are all connected to the ground. Now it is 0010 MSB, and this is the LSB, right? And then we have to take 3 input NAND gate, that to which we have to connect these values. So get into the 3 input NAND gate 7410, yes. So let us place that over here. So 1 is enough, so close this, then let me rotate. Control R is for rotation, so I'll be taking over here, right? So now let us make a confirmation which are all are input to this gate. So input is Q0, Q1 and Q2, right? Now let us get into the circuit. So this is Q0, Q1, Q2. Let us make a connection. So this is Q2, this is Q1 and this one is Q0. At output of this will be connected to the parallel load. Right, so the job is done. So as I told you before, once again, so I'll be making this as a default connection. So I'm not initially loading the value to the output, but anyhow after the first cycle by default it will be loaded. But anyway, let me have a try with respect to that also. Let me show that I have not shown that in the first case. Let me show that in the second case. For the first time I'll be connecting this to the ground. That is the ground line, so that the value can be loaded. Since I have connected it for 1 Hz direct clock, I may not be able to continue with the count because it is always connected to the load. Let me have that. So this is the truth table, right? So now it has been connected. The value 2 is being shown over here. Let me pause this run. Let me eliminate this connection. So I have to stop this. I cannot delete it. Now I'll be making the connection. Now here is the truth table, what you can observe. So now I am at this particular state. So I must go up to this point. This 7 must not appear, then 2 has to appear, right? Just make sure that 3, okay, 4, 5, 6, 7 is not appearing, right? So after this particular state it is 2, then 3, 4, 5, 6, coming back to 2, right? So this value 7 is not appearing. That means the circuit what we have done is now working in a perfect state. Thanks for joining.